is a persistent misconception that AI engineering requires patching together dozens of unrelated, disjointed software tricks to simulate intelligence. It does not. True agency relies on a single foundational cognitive architecture. It operates as a continuous loop. The system perceives an input, reasons about its context, passes its proposed response through a strict safety gate, executes the action, and learns from the outcome. The 30 specialized enterprise agents we build for modern production environments are simply this exact same loop deployed across different operational domains. To maintain stability across these domains, we enforce an absolute engineering rule. Text generation must always remain downstream of policy enforcement, factual verification, and state management. This is a guided tour through the complete architectural stack. We will examine how this single cognitive loop scales from a basic conversational interface up to an embodied physical system, tier by tier. Mapping this complete architecture is the only reliable method to transition away from deploying fragile, unpredictable Python scripts and begin building a resilient, enterprise-grade swarm. We begin at Tier 1, the foundational cognition layer, establishing the ability to act with intention. Agent 1, the autonomous decision-making agent, relies on a strict safety gate that knows precisely when an action violates operational limits, halting the process before damage. Agent 2, the planning agent, expands that temporal horizon. It takes abstract, high-level business goals and mathematically decomposes them into sequential, actionable steps. However, both of these systems suffer from the exact same structural flaw. When a session ends, their context buffers clear. They wake up to the next query with total amnesia. Agent 3, the memory-augmented agent, cures this amnesia. It structures information into a tripartite architecture: working memory for the active session, episodic memory for interaction history, and semantic memory for distilled factual knowledge. Mastering decisions, structured planning, and stateful memory is the mandatory baseline that transforms a stateless text generator into a continuous, autonomous mind. Moving to Tier 2, the system must acquire verifiable facts outside its frozen weights. Agent 4, the knowledge retrieval agent, queries external vector databases and physically staples a citation to every claim it generates. But retrieving data exposes a formatting problem. Feeding a complex corporate invoice into a language model as a raw linear text string destroys the grid's layout, disconnecting monetary labels from their actual values. Agent 5, the document intelligence agent, solves this by treating documents as images. It extracts text while assigning strict X and Y spatial coordinates, preserving the physical layout as searchable meaning. With clean data secured, Agent 6, the scientific research agent, reads the landscape. It clusters thousands of academic papers by semantic meaning to map current consensus and locate the exact hypotheses missing from the literature. Anchoring an agent's reasoning in structured, externally verified evidence is the only structural cure for model hallucination. In Tier 3, the architecture steps from internal cognition into digital execution. The AI must touch the real world. Agent 7, the tool-using agent, isolates the reasoning core to parse a user's intent, verify strict data schemas, and safely connect to external APIs without crashing. But asking one generalist to juggle 50 tools destroys its attention. Agent 8, the chain of agents orchestrator, assigns discrete tasks to a team of narrow specialists, entirely avoiding the context dilution that breaks monolithic models. Agent 9, the agentic workflow system, wires these specialists into durable state machines. The architecture allows the agent to safely pause compute operations and serialize its memory while waiting days for human approvals. When executing statistical mathematics, Agent 10, the data analysis agent, translates raw numbers into narratives. It works immediately alongside Agent 11, the verification agent, which acts as an empirical auditor to ensure the math is strictly computed, never probabilistically guessed. When specialists fail on completely novel scenarios, the system escalates to Agent 12, the general problem solver. This meta-reasoning engine evaluates its own failures, refines its hypothesis, and iteratively attempts a new strategy. Handing a large language model a set of tools without establishing these exact orchestration and verification protocols creates automated chaos rather than enterprise utility. Tier 4 is the interaction layer. Here, the swarm engages humans, writes code, and perceives raw data. Agents 13, 14, and 15 form a unified software development loop, passing logic through strict policy scanners and feeding failure telemetry back to improve the baseline model. Agents 16, 17, and 18 manage human relations. They serve as the engines for maintaining conversational safety, enforcing strict brand guidelines during content creation, and treating post-launch analytics as a reinforcement learning problem to optimize future engagement. This tier also controls perception. Agent 19, the vision language agent, bridges the gap to the physical world by computing joint probabilities over textual prompts and raw geometric pixel arrays simultaneously. Agent 20, the audio processing agent, moves beyond sterile text transcription. It splits a voice waveform into two parallel tracks, isolating the semantic words from the emotional acoustic prosody. To manage continuous environments, Agent 21, the physical world sensing agent, applies mathematical filters to asynchronous hardware data, stabilizing noisy signals into a reliable digital twin of a room. Establishing robust conversational interfaces and flawless multisensory perception are the mandatory prerequisites before an agent is allowed to trigger physical actuators. Tier 5 is the governance layer, engineered specifically for high-stakes, highly regulated professional environments. Agent 22, the ethical reasoning agent, relies on deontic logic to evaluate proposed actions against a mathematical rule set, explicitly blocking unsafe API calls before they execute. Agent 23 makes that internal logic visible. It captures an immutable, cryptographic trace of the system's reasoning path and calibrates the mathematical certainty of the outcome, replacing the black box with a forensic flight data recorder. With safety and explainability hardwired into the pipeline, Agents 24 through 29 act as the specialized domain deployments, architecture across healthcare, scientific discovery, financial advisory, legal intelligence, and collective education. In these regulated sectors, raw accuracy is cheap. Transparency and calibrated certainty are the only currencies that buy institutional trust. The final step in this framework is condensing this entire 29-node digital intelligence stack into a single logical core. That core is installed into Agent 30, Embodied Intelligence. This physical chassis relies on perception, orchestration, and reasoning layers to navigate three-dimensional space. Physical robotics cannot rely on database rollbacks. A hallucinated coordinate or an unverified action in the real world causes permanent structural damage. This exposes the throughline of modern AI engineering. An intelligent system is a massive liability unless it prioritizes structural safety, verification, and rigid governance over raw processing power. To access the complete architectural blueprints, execution protocols, and Python code required to construct these systems, refer to Imran Ahmed's textbook, 30 Agents Every OI Engineer Must Build. True agency is not a prompt trick. It is an engineering discipline, and building it means starting at Agent 1 and mastering the architecture of safety, step by step.